Okay, so we've got here a picture of three shapes. It says some corporate logos are distinctive because they make use of repeated shapes. Means they're using the same shape over and over and over. Okay, so we see there you got the three, looks like hearts, right, green hearts that are all, they're together. Right here you've got a repeated shape. This looks like a reflection, right? This one looks more like a rotation, a reflection here, and then this one looks like just translations, right? Moved it down and over, right, to use the same kind of talk that we used before we got out for Thanksgiving. Now it says a designer creates two versions of a new logo for the Bolt Company. Version 1 uses the original image shown at the right and a reflection of it. Version 2 uses reduced copies of the original image. It says to make a sketch of each version. So I want you to draw this bolt. And then version 1 wants you to reflect it on the right side, right? Shown at the right, a reflection. So I want you to draw what you think that reflection would look like on the right side. And then version 2, it says uses reduced copies of the original image. So what does that mean, a reduced copy? So reduced just means it's going to be a little bit smaller. Now it doesn't tell us how they do it, right? But you're going to use some versions that are just a little bit smaller. So I'm going to give you a couple minutes to do that, and then we'll see how we did. So hopefully you've got this done by now. So right here is an example. Again, it doesn't have to be exactly like this. But you can see here they've created their version 1. You see the reflection. Here's the original. And they reflected it this way. Again, you could have reflected it a different way. All right, but that's something that a reflection would look like. And then version 2, you see how they have scaled down and got reduced copies. So it's a smaller lightning bolt. And you see they've basically rotated that lightning bolt around. Right, something like that. Does it have to look exactly like that? No. Do they have to even be connected? No. You're just having to do something with smaller versions. Okay, now let's read these. If the owner of the company says, I like your designs, but it's important that the transformed image be the same size and shape as the original, what would you have to do in order to comply with these requirements?
Make it bigger.
Make what bigger?
The lightning bolts.
Why would you make it bigger?
I would make it about the
It's
same
important that
size.
the transform is the same size as the original.
Mm-hmm. So which one of these had the same size as the original? Version 1 does, right? So what could we do in order to make sure all of our lightning bolts were the same size as the original? Or we'd have to make sure we copied the original size. So what kind of transformations can you do that would keep it as the same size? So what are...
Rotation, reflection, or transform.
Uh-huh. Right, the three types of rigid motion that we just got done looking at, translations, rotations, reflections, they ensure that we keep it the same shape as the original. Okay. Suppose that there is some kind of rigid motion that can map one figure onto another figure. Why does this mean that the two figures are congruent? All right, so what does rigid motion mean? If our motion is rigid,
It stays the same shape.
same shape, same lengths, same angles. And so if I can take a figure, I can use only rigid motion, and I can make it map onto another figure, then that means that our two figures must be congruent, which means they are equal because I can map it onto its original. So like Look here as an example. So you can see they are looking at this figure here, A, B, C, D, E, F, right? Some kind of six-sided figure. And they're wanting to know, is it the same as this figure? Are they congruent? Well, they did a reflection. That's rigid motion. And then they did a translation. They went right 2, down 5. And you can see when they did that, it mapped exactly onto that one that is already drawn, the IJHGLK figure. So that means that those two are congruent because one maps onto the other using rigid motion. 90-degree rotation.
It depends on what, shape, what it is. If it's a circle, yeah.
If it's anything, yeah. 90-degree rotation doesn't change the shapes. It might change the position of the shape, but it's still the same shape in a different position. I'm not stretching it. I'm not shrinking it. I'm not destroying any part of it. Now, it doesn't have to have symmetry, right? It may not map exact. You're thinking of symmetry. Yeah, but rigid motion maintains the same shape even if you rotate it. It just may be in a different orientation. You know what I'm saying? So if I did a 90-degree rotation about the origin and I moved triangle PQR and it lined up with triangle LMN, can we say these two kinds of triangles are congruent? So basically what happened, they rotated 90 degrees, this triangle. When they did that, it mapped directly on top of triangle LMN. So are the triangles congruent? Yes, they are congruent because they map exactly on top of each other using only rigid motion. Rotation is rigid motion, so we didn't stretch it, didn't compress it, none of those things. Okay, so it tells us here, it says triangle XYZ is congruent to triangle ABC. So it tells me right off the bat, if they're congruent, that means there's some way I can map XYZ to be directly on top of ABC. And they want to know what composition of rigid motions will do that. So basically we're going to be doing what we did last section, except we're going to be coming up with how do we move it from XYZ here to ABC. And you can use any of the rigid motions that we have looked at. So what do you guys think? Now, here's a little hint that I want us to make sure we know. Whenever we line them up, the order of the letters that they tell us is important. The order of the letters is important. You can see here I have XY is listed first. And on this triangle I have AB is listed first. So that means this side, XY, needs to go on top of this side, AB. They need to match up because they are listed as the first two letters. And then similarly, YZ is second and third. BC is second and third. So that means YZ, which is here, needs to map onto BC, which is here. And then you can see how XZ is at the first and last, and AC are at the first and last. So I have XZ and AC. So I need to line them up where those colors will line up exactly on top of each other. So what kind of
180.
transformations we want to do? Okay, so 180, what am I going to rotate around 180? Rotate around what point?
-2. Yeah.
Okay, so we're going to rotate around point Z.
Yes.
Okay.
Because after that, you X and Y, X's and Y's will change. And
Okay,
then
so
D
let's
and
think
Y.
about if we did that in our heads. Okay, if we rotate it around point Z, I like it, then what is my new figure going to look like?
That.
It's going to be turned here, but is it going to be lined up exactly?
No, because then you have to translate.
Then we're going to have to translate it, right?
Translation.
You're right. Because Z is going to stay exactly in the same place. But you're right. If you rotate 180 around Z, that works. And then how much do I have to move Z over to line it up with C? I have to go right 1, 2, 3. So what we can do here is we can say, let's rotate this 180 degrees around point Z. And then what do we want to do? We want to translate it right 3 units. So that would be my transformations. That would be 2 of them. Are these the only 2 that will work? No. You could have rotated around a different point. You could have rotated around the origin. You would have had to slit it a little bit differently. You could have reflected it and then reflected it again, right? Think about if you took A or XYZ. If you reflected it over a horizontal line like this,
You reflected it over 2.
and then reflect it over a vertical line like that. So there's more than one way to do this. You just have to come up with a way. And then once you do it, prove that it maps directly on top of itself.
Reflect it over the origin.
Okay, well we can't
Horizontally.
so reflect over a horizontal line.
Yes.
So like this.
Yes.
Okay, so that would be the x-axis, right?
Yes.
Instead of the origin. So we could reflect over the x-axis. Okay, let's see what that would look like. So I would have G prime here. I would have 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3. I would have H prime here. 1, 2, 3, 1, 2, 3. And I would have J prime here. Okay?
You would reflect it over the Y.
Okay, then reflect over the y-axis. Okay, so let's see what that looks like. So if I reflect it over the y-axis, J prime is going to stay here. Let me use a different color. That's not going to show very well. Let's go here. So this is J double prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So right there is H double prime. And then G prime is at -7, so it will go to 7. So right here is G double prime, okay? And then what did you do?
Then you would take each point right 3 and then down 4.
Right 3, down 4. So let's see if I go 1, 2, 3.
Right 3, right 2.
1, 2, 3, 4. Okay.
I don't know why I said 3. I guess because
I said it'd be real easy to get off 1, 2. So 2 down 4, that works for that. For J, right 2 down 4. That works for L, right 2 down 4. Works there. Beautiful. Okay. Did anybody else do it differently? Anybody try a rotation? You have to either do 2 reflections or 1 rotation. You have to do one or the other. Okay, there's no way to get there without doing one or the other. That's perfectly fine. That works. So again, we're just having to find one.
JKL.
Okay, so you think triangle ABC is congruent with triangle JKL?
Angle ABC and angle EFG.
And so you think it goes with this triangle?
Yeah.
Okay. So how can we know which triangle it maps onto and be sure?
I'm currently measuring it with my pencil. Oh, do they?
Try to find a transformation that maps it directly onto it. Right? So let's try to move let's try to move ABC to FGE. Okay? So it looks like if this one will map onto this, they're already in the correct orientation. I just got to slide over, right? So how far do I have to move C over to get to G? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went right 10, and it worked. So that should be the same for all of them. If I move B right 10,
You have to move down.
it doesn't line up, does it? If you move A right 10, it doesn't line up. So we know A, B, C, and F, G, E, they don't line up exactly correctly. All right, but let's see. What if I tried to move A, B, C to L, K, E? Will they line up? How could we do that? Well, I would start by doing a reflection. What do you want to reflect over? I would reflect over.
-5 or 4.
You could do I'll do -4. You could do -5. You could do -3. There is no right or wrong. Just need to pick one to reflect it over. So if I do my reflection, then right here becomes C prime. 1, 2, 3, 4. 1, 2, 3, 4. Right here becomes B prime. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right here becomes A prime. And now let's see, if I try to move that onto this triangle, I'm going to go down 1, 2, 3, down 1, 2, 3, down 1, 2, 3, and they all fit where they should. So that means triangle ABC is congruent with triangle JKL. And now again, the way you name it is important. Look at how I named it. Look at A. Which point did A map on top of? J. Right, so you see how A and J are listed first. And then B, it mapped on top of K. So B and K are listed second. C mapped on top of L. You see they're listed last. Now you can rearrange it, like I could name this triangle CBA. But if I do that, I have to name the second one the same order. So C has to go with L. B has to go with K, and A has to go with J. So there's multiple ways to name the triangle, but however you name the first one, you have to make sure the second one matches that same flow, what it actually lines up with. All right, any questions there? Give me just a second. I gotta take a picture. This.
Reflect over the X,
Uh-huh.
then over the Y, then translate up. Yep.
Okay, so if I take this picture here, if I were to rotate it 90 degrees, about the center, and put it here,
Oh,
and then if I reflect it, I can line it up exactly on top of the other one.
that's dumb, though.
So that one is rigid motion.